Hello and welcome to this video tutorial on Open System Interconnection Reference Model. My name is Suresh and I'm going to explain to you why you must learn and understand the OSI layers. Firstly, this is a conceptual blueprint dividing the processes of communication into 7 logical layers, hence the term layered architecture. The OSI reference model was created by the International Organization for Standardization in the late 70s. The international standard defines networking protocols and their specifications. Now, there was a time when each vendor created their own specific networking protocols in order to network their branded computers. For example, IBM used SNA, which stands for System Network Architecture. DEC used DECnet, which stands for Digital Equipment Corporation Network. Novell used NetWare and Apple used AppleTalk. So they all had different specifications. But it was not ideal for each vendor to create their own networking protocols, as it made it difficult to interconnect computers due to compatibility. And so the OSI model was created to standardize networking across the entire planet. This reference model made it easier for vendors to interconnect machines. Whilst the OSI model was being created, another smaller project run by volunteers from the US Defense Department had started developing another networking model known as TCP/IP. Today, every Microsoft, Linux, and Unix operating system includes extensive support for TCP/IP. Even mobile phones operating systems support TCP/IP. This was made possible by 6 organizations that are responsible for the development of the Internet's architecture, the standards and policies, and related activities. You are unlikely to ever have any hands-on experience with the OSI model protocol specifications. The reason for this is because today we tend to use TCP/IP. TCP/IP is now one of the most prolific set of data networking protocols ever. The reason why CompTIA, Cisco, Microsoft, and many other IT courses need you to study and understand the OSI model is because all networking models and protocols, new and old, are classified against the OSI reference model for purposes of comparison. Within the OSI model, there are several layers which can be grouped into defined areas. The upper 3 layer functions are related to application interfacing, which means the application does not sit in the application layer, but the application interfaces with this layer. The bottom 4 layer functions are related to end-to-end delivery of data, sent or received from the upper 3 layers. So let's explain clearly what each layer is doing. So starting with the application layer, it defines the interface between the communication software and any application that need to communicate outside the computer on which the application resides. For example, a web browser is an application on a computer. The browser needs to get the contents of a web page, so the application layer defines the protocols used on behalf of the application to get the web pages. The presentation layer defines data formats such as ASCII and JPEG. Encryption is also defined as a presentation layer service. For example, FTP, which stands for File Transfer Protocol, can be used in situations where your email services has an attachment size limit, and you need to send a very large file. FTP enables you to choose binary or ASCII transfer. If binary is selected, the sender and the receiver do not modify the contents of the file. If ASCII is chosen, the sender translates the text from the sender's character set to standard ASCII and sends the data. The receiver translates back from the standard ASCII to the character set used on the receiving computer. This all happens behind the scenes and is transparent to the user. The session layer defines how to start, control, and end conversations, called sessions. This includes the control and management of multiple bidirectional messages so that the application can be notified if only some of a series of messages are completed. This allows a session layer to have a seamless view of an incoming stream of data. For example, a cash machine transaction in which you withdraw funds should not debit your account and then Before handing you the cash, record the transaction even though you did not receive the money. The session layer creates ways to imply which flows are part of the same session and which flows must complete before any are considered complete. The transport layer provides a large number of services. Although the above layers focus on issues related to the application, transport layer focuses on issues related to data delivery to the other computer. For example, TCP, which is defined as a transport layer service, performs segmentation of large application data blocks into smaller ones for transmission, and error recovery and reassembly of those blocks of data on the receiving computer will take place, making sure your web page or data is sent and received intact. The network layer defines end-to-end delivery of packets. To accomplish this, the network layer defines logical addressing so that any endpoint can be identified. It also defines how routing works and how routes are learned so that the packets can be delivered. For example, IP running in a router is responsible for examining the destination IP address of a packet, comparing that address to the IP routing table. IP at the network layer will fragment the packet if the outgoing interface requires smaller packets, and manage queuing the packet to be sent out to the interface. The data link layer defines specifications of particular link or medium to deliver data across it. These protocols are necessarily concerned with the type of media in question. For example, the 802.3 and the 802.2 define Ethernet for the IEEE, which are referenced by the OSI as Valid Data Link Layer protocols, also referred to as MAC and LLC, respectively. Other protocols such as high-level data link control for point-to-point WAN link deal with the different details of a WAN link. The physical layer specifications deal with the physical characteristics of the transmission medium, such as connectors, pins, use of pins, electrical currents, encoding, and light modulation are all part of a different physical specification. Multiple specifications sometimes are used to complete all details of the physical layer. For example, RJ45 defines the shape of the connector and the number of wires or pins in the cable. Ethernet and 802.3 define the use of wires or pins 1, 2, 3, and 6. So to use a Category 5 cable with an RJ45 connector for an Ethernet connection, Ethernet and RJ45 physical layer specifications are used. So to sum up, here is a list of example protocols and components you can expect to find on each layer. I suggest you pause the video and spend some time viewing this table. Earlier in this video, I mentioned that the TCP/IP model is the winning model and has now been adopted by nearly all networking structures around the world. Here in this table, I am comparing the 4 layers of the TCP/IP model against the 7 layers of the OSI reference model. I suggest you pause the video again and view the TCP/IP protocols that exist at each of the 4 layers. Many benefits can be gained from the process of breaking up the functions or tasks of networking into smaller chunks, called layers, and defining standard interfaces between these layers. So it's easier to learn because we can more easily discuss and learn about the many details of a protocol specification. It's easier to develop because it helps to simplify program changes and faster product evolution. Multi-vendor interoperability means all networking devices can speak together through a common structure. Modular engineering allows one independent vendor to write software for a higher layer, while another independent vendor writes software for a lower layer, but maintaining interoperability. I hope you found this video useful. Please post any comments to my email address, and thank you for taking the time to watch this video.